Okay, so now we have our character, and our character responds to physics. The character also has animation set up. However, we haven't triggered any animations yet except for the idle animation. So now it's time to write some code. If coding is part of the game development process you don't really like, then there's not too much I can do to help you with that. It's just one of those things that you're eventually going to have to deal with. I've been writing code for about 15 years now in a bunch of different languages for many different purposes, and I quite enjoy it. For me, it's a rather relaxing and enjoyable experience, and when you hit build and everything works, it just feels wonderful. Especially when you've spent the time to build out the code yourself. So that's what I encourage you to do. Try and write some of the code yourself before I explain how to do it. Just to see if you're able to come up with something similar or even better. There's no right or wrong way to do things. There's best practices. Those we're going to go over in the more advanced section. But ultimately, if you can get the game to work, then that's a really good start, especially if you're just in the prototyping stages. So the programming language we're going to be using in this is C#. It's a very common Windows-based language. If you haven't learnt any other languages before, it's really quite a good one to get started with. Unity also allows for JavaScript and BoostScript, but I think you'll find the most commonly used one is C#. If you've never written code before, I highly recommend taking a Fundamentals of Programming or Fundamentals of C# course, just to get up to speed on the basics. But I'm going to walk through this slowly to start with, so hopefully you'll be able to follow along even if you haven't coded much before. So I'm going to come down to my scripts folder, right click, create, C# script. Let's call this one player movement. Okay, now double click on the script. Okay, now the script will open up in your default editor. Now normally this will be called MonoDevelop. MonoDevelop is the standard editor that comes packaged with Unity 3D. I'm using a different editor called Textastic. You can use whatever you want. MonoDevelop is a good one to stick with if you're happy to use it. I'm using this one simply because I can make the text really big and stand out on video, and it's nice and clean to work with. If you continue to work with MonoDevelop, you can copy everything that I'm doing here and you won't have any problems. It really doesn't matter which editor you use. It's just a very standard text editor. Okay, so this is the default template you get when you create a new script. You'll be using the Unity engine, system.collections, and we're creating a public class called player movement because that's what we named the file. You can change this class name if you would like though without having to worry about the file name. And it's going to inherit from the framework of MonoBehavior. And if you watch my MonoBehavior video earlier, which I highly recommend watching before taking this course, you'll understand what these functions here are for. So start is in your initialization process, so start will be any code you want to run when this component is initialized. Update, it will be part of your update loop. So any code you put in here will occur every single frame. Okay, let's start by adding some instance variables at the top here. So instance variables are variables that will exist only as long as the component exists. The variables are there specifically for this component. Other components can access them externally if they're public variables, but mostly it'll just be this component that's making changes to them. If you haven't come across the term variable before, I highly recommend the Fundamentals of Programming course for you, as a detailed description is outside of the scope of this lesson. So a variable can either be private or public. So private will be for use just in this component. Public means that it can be changed by other components. So let's start by making a private rigid body 2D. And let's just call it RB. Now C# is a case sensitive language, which means if I was to start this with an uppercase P, it wouldn't work. So that's just something you need to be conscious of. Rigid body 2D is a built-in component type. You'll remember adding a component of rigid body 2D to your character in a previous video. So what we're trying to do here is access a component from the game object. So this is how we gain access to the rigid body 2D for whichever object that this script is going to be attached to. We also need a link to the animator. So private animator an semicolon. Now right now those two private variables aren't attached to anything. So if you try and use them, there's not going to be anything there. So in our start function, when this component is initialized, we want to make a link to the rigid body 2D and the animator for this game object. And this is how we do it now. So RB, which is this variable up here, equal to get component rigid body 2D. So it will get the component from the game object, which is the rigid body 2D. And same for the animator. Now because I'm attaching these in a prefab, I know they're always going to have a rigid body 2D and an animator. Okay, now just about every single thing that's going to happen on this component will be affecting the physics engine. So whether the character's jumping or moving, it's going to take place at the physics engine. So I'm just going to change this update to a fixed update. This means the update will occur as part of the physics loop as well as the game loop. Okay, now we just need a few more instance variables. So we're making 3 public floats. One of them is the movement speed. So this is going to be the speed at which the character moves. The next is the jump force. So when you apply a physics force to the character to jump, this is how much force you are going to apply. Then there's the maximum speed. So as the character moves, they will gain more momentum and speed. The maximum velocity just caps that off so that they don't reach their maximum velocity. So that when they reach their maximum velocity, they're not going to go any further. Okay, so in our fixed update, first we want to create a variable for the force we are about to apply. So this will be a variable, var, force, equal to a new vector 2. So a vector 2 is an object that is made up of 2 floats, generally representing a x and y axis. So in this case, if force is in the x-axis, the character would move left and right appropriately. If the force was in the y-axis, the character would move up or down accordingly. Okay, now we're creating a new float called move horizontal. So this is your input for your horizontal movement, your left and your right. And that's going to be equal to input get axis horizontal. Okay, so what we're doing there is we're collecting an input with the name horizontal. If I come over back to Unity, under Edit, there's Project Settings. From there, select Input. Over here in the Inspector, you can see the Input Manager. The inputs in here are a lot of defaults. One of those defaults is horizontal. So that is the value that we're looking up. And if we have a look in here, the name is horizontal. It receives controls from the left and right button, also the A and D button. And then it has some settings around the sensitivity. So it's going to be a key or mouse button, or it can even come from a joystick. So you'll find once we set up these controls, if you have a Xbox One controller plugged into your Windows PC, you'll be able to play the game with the controller straight away. And that's where using this input manager is really handy. It's one spot where you can set it all up, and then you just have to call each of the values by name as you need them. Okay, so what we're doing here is we're collecting the input for horizontal and storing it in this float called move horizontal. Next we want to find out the velocity of the current rigid body 2D. So we use 2 variables here, one for the x-axis, one for the y, called ABS velocity x and y. From there we use this function called mathf.abs for absolute, and we're asking the rigid body that we set up here what its velocity is in the x-axis, and same for the y. From there we check if the character is currently standing on the ground. The way we do that is checking the y velocity, which should be 0 if the character is on the ground. That means they're neither moving up nor down. And just remembering we're doing this check every time the update loop runs. so it should be fairly accurate. So if absolute velocity y equal to 0, then the character is grounded. And we are setting grounded to true. Grounded is the private boolean we set up here, so booleans are yes or no statements. If the velocity is not equal to 0, then grounded is going to be equal to false. And I just wanted to point something out here. Because we're checking a value here, we're using double equal signs. Because we're setting a value here, we're using a single equal sign. Now at some point while programming, you're probably going to use a single equal sign, and it's going to drive you crazy. It's hard to debug and it takes forever to find where you've messed up. So make sure you're using double equal signs. Otherwise, what you're actually going to do is set the ABS velocity equal to 0. The next thing we need to do is set the force in the x-axis. So this is going to be the direction that you're walking in. So if the current velocity of x, which you found up here, is less than the max velocity of x, which you have defined up here, then force.x is going to be equal to your movement speed times move horizontal. So that is a horizontal movement that you grabbed from up here. Your horizontal movement is going to be 0 if the character is not moving, -1 if it's moving to the left, and 1 if it is moving to the right. And if you're using a controller, it might be a decimal place in between one of those, so 0.5, 0.6, -0.5. Okay, so that's how you define what your force is going to be. And also note that we're just setting the x value of our vector 2. Okay, so that takes care of the force for our movement. Now what about jumping? So we want to do another if statement. If grounded is equal to true and input get button jump, so the jump button has been pressed, then we're going to run this function inside the curly brackets. So we're going to set grounded to false because we're jumping. Force.y is going to be equal to the jump force. So now we're affecting the y-axis and adding to it the standard force of a jump. And here we're actually going to set our animation state now. So we created a link to the animator up here. Now we're saying an set integer for anim state. That's the name of the parameter. And we're going to set it to the value of 2, which if you remember is our jump animation. Now after doing all that, we've set up our force, so we need to apply the force. So we're saying our rigid body, we want to add a force, and it's going to be force. So that will cover any of our left and right movement and also our jump movement. Okay, now save your script, which in my case will be Command S, it could be Control S on yours. Just make sure that you're saving the script. Jump back over to Unity, and when you click on the script, you should see over in the inspector that it is updated with the code you've just added. Now if you select the player character, you can select Add Component, Scripts, and your player movement script. Okay, now you see those variables that we marked as public variables? You can actually edit them from the inspector. And every time you edit them, that won't affect the actual script, it will save it to the prefab. So if you add the script to something else, it will revert back to these defaults on that other thing. And once again, you can change them to be specific to that prefab. Okay, let's play and see how that looks. Okay, and you can see my character will move, but they're rolling. We'll have to make a few changes to the rigid body. It appears to be jumping correctly. The animations do not appear to be working though, so that's something we'll have to look at. Okay, let's start by going back to the rigid body of the player and have a look under constraints. You can freeze position. So I'm going to freeze rotation in the Z-axis. Now if I hit play again, and the player no longer rotates. Okay, now let's fix those animations. Come back over to your script, and under rb.addForce, we're going to add the following if statement. So if move horizontal is greater than 0, so we're saying greater than 0, it can be any number above 0, but not equal to 0. We want to set the transform local scale to a new vector 3 of 1, 1, 1. So what does this line here mean? Let's jump back over to Unity. Let's have a look up in this top section here, which is the transform section. And over here, this is our local scale. So when the horizontal movement is greater than 1, meaning they're moving to the right, we want the scale to be 1, 1, 1, just like it is here. Whereas if we're moving to the left, if we change the X scale to -1, you'll notice that the character faces to the left. So by changing the scale, it's a really quick way to switch the direction that the character is facing. So that's what we're doing here. We're setting the transform to be facing in the normal direction, else if move horizontal is less than 0, we're changing the x-axis to -1, so it'll actually be facing to the left. And then if the move horizontal is exactly 0, it'll go through to this else statement, where it's not going to do anything. It's just going to stay facing in the direction that the character was last traveling in. Now here you'll see we've also added if statements for if grounded. We want to set the anim state for both of these to 1. So that means they're running. If they're standing still, then we're setting it to 0, which means that it goes back to the idle animation. So now we've covered jump, running, running, and idle. So let's go back into Unity now and hit play after, of course, saving. Okay, so the character's now moving around, but the animation isn't quite fixed yet. You can see in the sprite renderer, it's cycling through the idle animations fine, but it's not actually switching to different animation. So why is that? Okay, let's see what's going on here. If we go to player character in your hierarchy view and select animation, not animator, you can see here it is on character idle. It's sampling at 12 frames per second, and these are each of the frames, so that's okay. We go to character jump. We don't have any frames in here, so something went wrong in that process. So I'm just going to select the 10 frames for character jump again, and drag them onto this area here. And notice how they're all squashed up like that. That's because it's sampling at 60 frames per second, and we would prefer 12. So I've set that down to 12. Okay, that looks a lot better. Now let's go to character run. We've got the same issue over here. So this is the problem we were having before. There's just simply nothing to animate. And 12. Okay, now that should have fixed our animations. Come back to scene, select play. Okay, you can see when I'm moving, it will change, but it's not 100% fluid. And when I jump, it keeps doing the jump animation long after it should. So there's a few things we have to fix up still. But it does change animation, so that's positive. So let's come back into the animator, and we'll start by selecting the transition from character idle to character jump. Okay, over in the inspector you can see that by default it has an exit time. That's not what we want. We want it to instantly exit out of the idle state when it goes into a jump state. So I'm going to untick has exit time, and I'm going to leave the others as they are. Now I'm just going to work through every single one of these transitions and untick has exit time. Now when I select play again, you'll see as soon as I'm hitting the keys, I'm getting a much faster response. So the character movement looks a lot more fluid. Now when I jump, you can see it still cycles through the jump animation over and over again. So let's have a look if we can fix that one up as well. So if I come over here now, you can see on my character idle it has a loop time, and that's fine because we want it to loop over and over again. The jump on the other hand, we only want it to play once, so I'm just going to untick loop time, and run we want to loop, so that's fine as it is. So if I build and run again, no problem, it stays on the last frame until the character lands on the ground. Okay, and now just in these few short lessons, you've completely animated your character. It can jump and move around the scene, and as you create new scenery, it will be able to navigate through it. And you'll notice that we actually didn't write that much code to get to this stage, so that was pretty cool.